Hello everyone, welcome to Reliability Insider channel. In this video, I will explain the well-known Crow-AMSAA reliability growth model in 5 minutes. Very simple and practical. First, what is the model about? You can simply consider the model as a power function to describe the relationship between cumulative failures and the cumulative time. So for each calendar time, you calculate n and t, and over time, you will have a set of n and t to fit the function to get the parameter beta and lambda. And here the failures can be from different failure modes and different parts. And here the time t can be expressed in hours, days, weeks, months, or years. In my work experience, I have seen people struggling with finding the data trend from failure count as a certain calendar time intervals, or they are trying to find the data trend from the moving average of over certain times. That is not what the model talks about, and that is also not what the math function talks about. Going back to this equation, if you rewrite it in the log scale, here you will get a linear relation, and that is why you will often see a Crow-AMSAA plot in the log scale, where you have beta equals to the slope, and it reflects the reliability growth trend. And you have the log lambda equals to the intercept at the y-axis when time equals to 1. And you will also see a case that when beta equals to 1, and what will happen is n will be equal to lambda multiplied by t. And in other words, what you are going to see is you will find out that the cumulative numbers of failures increase linearly with the cumulative time at a speed of lambda, which indicates a steady stage. And that brings to the next slide. What information can you get from the model? First, when you have different failure modes in the system, what the result of the reliability is a combine of old failure being resolved and the new failure coming up. So when you have beta equals to 1 and you say that your reliability is stable, what that means is that you are going to see a stable increase in the number of cumulative failures with the cumulative time. And when beta is larger than 1, that means the slope is larger. And at the same time interval, you will see more cumulative failures than that at the stable stage. And that means that at this same amount of time, there are more new failures coming up than the resolution of all the failures as compared to the steady stage, and your reliability is getting worse. And when beta is smaller than 1, that means that you are going to see less number of failures than the stable stage, and your reliability is getting better. And this number beta and lambda combined with the few math equations can be used to do some very powerful calculation to predict the futures, such as the future failure count, or the future mean time between failures, or the failure intensity. And for the time's sake, I will just list the calculations, and you can use it for future, and I will cover that in later videos. Now you have a better knowledge and a basic understanding of the model. How will it help you? I bet you will need it when you have systems like repairable systems, meaning that your parts get failed and replaced, but your system remains in the service. And then it also comes in the cases that when your systems are in the controlled or similar environmental conditions, such as you have equipment in the clean rooms, or you have medical devices in clinics, or you have computers in data centers. And those systems will have different failure modes, including infant mortality, random failures, and wear-outs. And over time in the field, you will do multiple changes, such as trying to improve your design, your processes, or do some field service actions. And all you need to do is you are trying to bring the reliability to an improvement and or stable stage. But you want to find out that whether it is doing so. So you will need to ask questions and have answers like this. After making changes to our new design, is the reliability getting better? Or after implementing corrective actions to NPI product in the field, are we seeing reliability growth? These two questions can be answered by finding the beta and compare the beta with 1. And then you will also want to do some calculation, such as to estimate the mean time between failure in the near future. And you can pick the instant MTBF equation to do this. And if you want to know that how far away from now to reaching a certain reliability target, what you need to do is to still use those equations, but back calculate the time, given an instant MTBF or failure rate as your target. And that's it. I hope you enjoyed the video, and for more updates on videos or courses, please subscribe to the channel. Thank you for watching. Bye bye.